Alright, welcome to this new series. We've got the important part. We're going to be looking at the important parts of different maths papers. Today we're going to be looking at the GCSE Further Maths 2023 Paper 1, non-calculator. We'll mostly be looking at GCSE Maths, GCSE Further Maths, and maybe AS and A-level Maths and Further Maths as well, when we get there. Alright, so for the first bit, this is just the easy stuff. Again, if you struggle with these, maybe go back to the previous difficulty of maths. So first, we've got this god-awfully easy function question that is number 1. Literally all you do is make it equal to -5 and solve. Next bit, just substitute. It's really easy. Next bit, it's not even that. It's like, I'm not even going to show it to you, just do it yourself. Alright, so here's some other questions that I'm not going through. Got this, just use Pythagoras for this one. Just use the gradient. Easy. This is easy proof. Just take them away from each other. This is just easy rearrange. It's not that difficult. Alright, this is filler. This and these two are both just more GCSE stuff. So, also, I hate completing the square, especially when the coefficient of A is greater than 1. So I'm just not going to do this one, even though it is quite late in the paper. Right, let's go on to the actual questions now. Right, firstly, we have a very easy matrix question compared to what you probably could get. Firstly, for the first question, you're just going to apply them all to one point to see what happens to them, to see which one reflects in this line. So first one, we just put this one, 0.10, you get 0, -1. Then you see, yes, this does reflect, so yes, and put a circle around it. For B, just multiply two matrices together as it says, you do all this stuff, get this, multiply out, -2, there's your K, and you've proved it right there. Next, we got some easy tangents to a curve stuff. Again, pretty textbook. Just find dy by dx, as usual. Substitute the x coordinate. You got the y equals here. You got the equation of the line. Substitute the point in again. C equals -16. There's your equation. As you can see here, we got the equation here. This is just the x-intercept. This is the point where it goes on. Alright, this question is just long. It's not that difficult. It's just multivariable algebra. So we're going to find the cone, which is just 1/3 pi r squared x. It tells you here. Find the prism, half xy squared, because it's a triangle. So we're just going to make them equal to each other. We know that this is 4 times this because it says here. So then we're just going to cancel out the x's. We're going to multiply it by 3. We're going to divide by pi, and then we're going to root it. So just a lot of rearranging. That's really it. Right, so we've got some more higher stuff, but it's 6 marks, so it probably is worth mentioning. The only difficult part that's like different to normal maths is finding the equation of the circle, which really is not that difficult. You don't actually need to find. Then you can just rearrange this one, substitute it into the circle equation, expand the bracket, simplify, divide by 5, factorize y out, get your y's, get back to this equation. You get both your x values just from this. It's just, probably would not get this many marks. You probably only get 5 for this in a GCSE, but Further Maths is a lot more giving with the marks. Alright, and you can see here we got our points. So this rationalised question usually is really easy. You should probably know how to do this. It's kind of normal GCSE. Just multiply by the conjugate. You know what you're doing. Expand, divide, you got it. But there's this funny method that I found, or someone else found, that we're going to try. You just know this is 1/4 times 4. You got this 4 equals 9 minus 5. That's the difference to 2 squares. Cancel them out. The 1/4 goes at the bottom. Expand this, and you get the same thing. Just a much more interesting way to do it. Right, so final easy question. We got the double derivative. It does not look that difficult at all. It's not showing you to apply it. You're just doing it. So just find it. It's made it pretty easy for you here because you multiply it by 12. Make it equal to 55. Take away 6. Square root. You get plus or minus 7, but it does say positive, so x equals 7. Not too difficult there. Right, so this is a quite interesting trig question. This is after the filler question. The main thing you need to know is if you want root 3 times something to equal 1, you need it to be the reciprocal of that number. Therefore, we know that y has to equal 1 over root 3. And we know that tan 30 and tan 210 from their exact trig values and trig graphs should equal 1 over root 3. So y equals 30, y equals 210. Pretty, not too difficult technically, but you have to see it to see it. Right, we've got some index laws here. This shouldn't be too bad. The only thing you really need to know is that it's a double bracket, which some people may miss out. After that, you just expand the double bracket, get this, use your power laws. You take the stuff from the other side, add them on, factorize x squared out, x equals 0, divide by x minus 3, divide by x squared, you get x equals 3. That's it. Alright, for the next question, we have Pascal's triangle. Now, I hate Pascal's triangle, so I've kind of just copied the mark scheme here. We're going to expand this one, get the coefficient of x squared, multiply by 6, 12, 12, get that, get 48 from this one, just divide 864 by 48, 864 is just this, get 18, 8 equals 18. Sorry about not having any detail working, I just hate Pascal's triangle. Alright, this is a very, very difficult question, by far the most difficult question on the paper. We're going to see it has a stationary point of negative 211, but before we do anything, we're going to find the derivatives, because whenever it's a stationary point, you should always find the derivative first. Next, we're going to substitute this in, as we know that this should work, into the main equation. We're going to substitute the 2 points in. We're going to get this equation of the a's and b's, and we're going to set this as a note up here. We also know that the derivative will also be on the point negative 211, because it sits, because it's a stationary point, so it sits on the curve. So we also know that this is a point, so you can substitute negative 2 into this and make it equal to 0, because we know the derivative is 0. And we also, so then we multiply, we get 12a minus 4b, which is 3a minus b. And now we have simultaneous equations of a's and b's, which we can find out through simultaneous equation methods, which after this point is not that difficult. It's just getting to this point is the difficult part. So we just add them together, we just get a equals 1, substitute it back in, you get b equals 3. But this first part, you have to, knowing about the derivative, substituting that in, substituting it to the main equation to get a simultaneous equation, it's just a bit difficult, especially for 5 marks. Alright, this is another long question. It's an easy version of a 3-way simultaneous equation. We're just going to substitute this one, put it into this bottom one here, expand it, move it. We're going to get z plus 4x equals 19. Then we're going to multiply it, because we know that x plus 3z equals 2. We're going to take away this one, 3z plus 12x, from x plus 3z, and we're going to get 11x equals 55. Sorry about no visuals there, but we've taken away that one from the middle one in the question. X equals 5, and then this next bit's pretty easy from here. You just get y equals 3, z equals negative 1, substitute them in. Sorry, it might have been a bit fast there, you might want to take a look. Right, so this last question is for a Further Maths GCSE final question. This is not that difficult. We know that just because I can't be bothered to write the angle symbol, we're just going to say that if I write POR equals 120, this is what I mean. So, firstly, we know that this is an easy bit. PQI equals 60 because the angle at the centre is half the circumference. We know this because, no, the angle at the centre is double the angle of the circumference, sorry. Then we use cosine rule to find PR, as we know this. If we ignore PO and OR, we can find this area. Just use this. Cos 60 equals a half. Simplify, simplify, simplify. Root, we get A equals root 21. Alright, so now we know that ORP and OPR, they both equal 30 degrees because this is an isosceles, because they are radii. And we can now use sine rule because of this, because we found this side. And we know that, so root 21 over sine 120 times sine 30 will give us any of the radii, it doesn't matter. We know that sine 120 is root 3 over 2, so if we flip this to get 2 over root 3, we get 2 root 21 over root 3, and sine 30 is a half. So we know that if we divide through here, sine 30 equals a half, we get this, r equals root 7, and we know that k equals 7. Alright, thanks for watching, guys. We'll see you next time. Sorry if it was a bit fast, but you can pause it midway through to see the working if you want. and happy revision.